All right, IM2 classes. Today we're talking about similar polygons. Something you may have learned in IM1, but just a little bit of review for us. What we need to remember about similar polygons is that they're polygons, so their shapes, they have the same shape. They're just different sizes. Specifically, the sides are different side lengths. The angles are all the same measure. So in our example here, um, so you can see the angles match up, they're all the same, and then just the sides are a different side length. We also say they're proportional. So we find the same constant. If we multiply that each side by that same constant, say it's like 2, you get the sides here. So each side is proportional. Let's look at an example here. So in the diagram, we have triangle RST. The wavy symbol means similar. So triangle RST is similar to triangle XYZ. Um, so that means these side lengths, they're match them up. So what we want to do to find the scale factor, that is what we'd multiply one triangle by to get the length of the other. All right. So I'm just gonna. It doesn't matter which way you set up this fraction. The scale factor can be either or. I'm going to just look at where's my. Oh, I didn't turn my board on. I'm trying to write and I can't because I didn't turn my board on. Now it's on. Um, Let me get out the highlighter here. So first thing we want to do is make sure we match up the sides correctly. So RS, so I'm going to look at this similarity statements. RS, why is it doing now? My board is being, here we go. RS, so that's this side down here, corresponds to XY. So you can match up the statements. This is something you should remember for IM1. RS corresponds to XY, and it's based on how they are listed. The vertices are listed in the statement here. These sides are proportional. We're going to use those two to set the scale factor. Real simple to find the scale factor. All you need to do is set a fraction. So I'm going to do RS over XY. And that's going to be 20 over 12. This is part A. Reduce fractions where you can. So 20 divided by 12, 20 over 12. I can divide top and bottom by 4. So that's going to reduce to 5/3. All right. So we say our scale factor K is 5/3. So part A is done. List all the pairs of congruent angles. That should be pretty easy here. Part B. So angle R, and we can just look at here. So angle R is congruent to angle X. Remember, the congruent symbol is an equal sign with the wavy line on top. Congruent to angle X. Then the next one, so we have S. I'm going to use a different color. So S and Y are listed next. So angle S is congruent to angle Y, and we can see that in the diagram as well. Yeah, I should mark these off as I do that with the congruency arcs. And so T is congruent to Z. The reason why I like to look at the statement is because sometimes the diagrams are orientated different ways, so it doesn't match up nicely like this. These are just listed out perfectly orientated the same way. Sometimes it's not like that, and so you want to look at the statement here just to be sure. That's supposed to be a T that got cut off. So angle T is congruent to angle Z. Done. Write the ratios of the corresponding side lengths in a statement of proportionality. We can see the statement of proportionality. Okay, this one's kind of unnecessary, but we'll go ahead and do it. So RS over XY is going to be equal to TS over ZY, which is going to be equal to RT over XZ. And then we can do it with the numbers. So that's 20 over 12. TS is 30 over 18. And that's going to be RT is 25 over 15. And if we were to reduce all those, they would be equal to 5/3. But that's just all we need to do. I think really this is the statement of proportionality that the book would be looking for. But these are all, if you reduce, they all reduce down to 5/3. And again, if you prefer, we can do like XY over RS. We can flip all these around. It doesn't matter which way you figure out that scale factor or write it out. You just need to stay consistent. If you do the smaller sides on top on one side, you need to keep the smaller side on top on all. Here, now we're going to use corresponding lengths to find missing side lengths. So we're looking for EF here. All right, if we look at, I'm going to set up a proportion. So here I have DE, I'll go DE. You know what? Yeah, no, DE is similar to MN. So MN. And then the EF. So I'm looking for EF. You know what? Let me start this over just so I change my mind on how I want to actually do this. Okay. First thing I'm going to do is I'm going to write the side length that we are looking for. Yeah. So here, nope. We are looking for EF. So EF, what is EF proportional to? If we look here, EF, NP, we can also look at the diagram, but NP. And now we need a side lengths that we know. I'm going to use just, I don't know, 20 is calling out to me. I'm going to use DF over MP. So what I did before is I just started writing ratios. I think it's easiest if you actually start with the side you're looking for, start on top. And so it's going to be X, NP is 30, is equal to DF, which is 20 over 24. So if you want, we can reduce this fraction on the right, or we can just cross multiply and solve. But that's all this is. We just got to cross multiply and solve. So if we cross multiply, it's going to be X times 24, which is going to be 24X. And then is equal to 30 times 20. If you want to work with smaller numbers, that's fine. You can do that. But it's going to be 24X is equal to 30 times 20 is 600. And then the next step, divide both sides by 24. So that'll cancel out. You get X is equal to 600 divided by 24. That's 25. There we go. Let's do another one. All right. So I'm looking for BC. So BC, if we look, that's listed in the middle. BC is congruent to RS. They are listed there same. So RS, I need a complete side. I'm going to do AB 12, and then QR is, hold on, AB and then QR. So listing out proportions. So BC is X. That is similar to RS, which is 4. AB is 12, which is similar to QR, which is 6. This one actually is easier because to reduce this first before cross multiplying, 12 divided by 6 is 2. And this one, you could probably, if you look at it, you could figure this out in your head without having to set up the proportion. You can see that all these sides on the bigger quadrilateral are double these sides. So you can very easily do that in your head if you wanted to. You don't have to set up the proportion, but for here, it is good practice, set up the proportion. There we go. Next example. So here we need to look at these marks here. I'm gonna label some things just to help us out. So JM is the same length as ML. We can tell by the congruency marks there. So this is also 48. HE is going to be 40 because it's congruent to GH. So this is 40. We are trying to find KM, which is X here. So this one is not included in the congruency or in the statement. There's no M in our statement here, but that's okay. Yeah, what we can do, since it's cutting things in half, there's a couple different ways to go about it. We can see that KMJ would be similar to FHE. All right. We could also, this is going to be proportional to this side here. I'm going to do KM over, I'm going to say JM. And that's going to be proportional. So it's going to be FH. So KM. No. I did that backwards. Even though this would work this way, did that backwards. Let me highlight. So no, I don't want a black highlighter. That's not helpful. This KM corresponds to the FH here. And then I'm going to use JM, and that is going to correspond to HE. So let me highlight that where I'm seeing those. We will use green. So I'm using JM and HE. Those are going to correspond. So KM is X, FH is 35, JM is 48, HE is 40. Again, you can reduce if you want. No, I'm just going to multiply. We have calculators. Sometimes it's just easier to multiply if you have calculators. So cross multiply here. So when I cross multiply, I get 40 times X is equal to 35 times 48. So that's 40X is equal to 35 times 48 is 1680. And then divide both sides by 40. It's going to be 42, I believe. I'm going to check my math here. Yeah, 42. So X is equal to 42. There we go. So there we go. All you're doing is setting up portions to solve missing side lengths. Just pay attention. You're setting up to the sides that correspond to one another. Yeah, so set up what you don't know compared to what you know on another side and get it going that way. And that will be it. Next time we're going to be doing similar right triangles, focusing specifically on right triangles.